Welcome back to our IB Physics video series. This is the fourth video in IB Physics Topic 5, Electricity and Magnetism, where we will be looking at electrical components, including resistors, monitoring devices, and power supplies. Make sure to watch the third video in our IB Physics Topic 5 video series before starting this video. In this video, we will expand the range of electrical components introduced and categorize them into three types. Let's start with resistors. Resistors are an integral part of any circuit, as they are used to limit current, divide voltage, produce feedback loops, set circuit states, test circuit designs, and alter an electrical signal's amplitude. The different types of resistors you need to be aware of are constant resistance, light-dependent resistors, thermistors, variable resistors, potentiometers, and lamps. A constant resistor is simply a common resistor capable of maintaining a constant resistance. A variable resistor is a length of wire with an adjustable contact that allows the resistance to manually be changed. A potentiometer is effectively a variable resistor, but the contact is connected to a new circuit branch. This gives a greater resistance range than a variable resistor. A light-dependent resistor is a variable resistor whose resistance depends on light intensity. These typically decrease resistance as light intensity increases. A thermistor is a variable resistor whose resistance depends on temperature. These typically decrease resistance as temperature increases. In your IB Physics exam, you are expected to calculate the voltage drop and current associated with these resistors, as covered in our previous video. However, in certain arrangements, some of these can also be used as monitoring devices. Monitoring devices are used to measure electrical parameters of a circuit. The ones you are expected to know are voltmeters, ammeters, and variable potential dividers. Each have special requirements associated with them, so let's go through each one. A voltmeter measures voltage over a portion of circuit, but it must be placed in parallel with the monitoring portion. There are two types of voltmeters, ideal and non-ideal. An ideal voltmeter has an infinite resistance and so does not cause a voltage drop itself whilst operating. It therefore accurately measures the voltage drop across a component. A non-ideal voltmeter has a constant but finite resistance, so it will cause a slight voltage drop when operating. In real life, most voltmeters are non-ideal. An ammeter measures current over a portion of a circuit, but it must be placed in series with the monitored portion. Like voltmeters, they can be ideal and non-ideal. An ideal ammeter has zero resistance, i.e. it does not contribute to the circuit resistance, and so does not decrease the current. A non-ideal ammeter has a constant but non-zero resistance, i.e. it does cause a slight drop in current. In real life, most ammeters are non-ideal. A variable potential divider is a circuit arrangement specifically made to divide a range of voltages, with the end goal being to measure a component's voltage-current relationship. This can be made using a variable resistor or a potentiometer. A variable resistor potential divider circuit looks like this. Here, the voltage drop range across the component is dependent on the minimum and maximum resistance of the variable resistor. A potentiometer potential divider circuit looks like this. Here, the voltage drop range can go from 0 volts to the power supply value, the maximum possible voltage drop range. It is for this reason that a potentiometer potential divider circuit is preferred. For those of you studying IB Physics higher level, the additional components, transformers, diodes, and capacitors will be explored in our Topic 11 video series. Now that we know about the different types of resistors and monitoring devices, let's cover the components that allow them to work. Power supplies. The types of power supplies you need to know of are electrical cells and AC supplies. All students need to know electrical cells in detail, but AC supplies will be covered in our higher level video series for Topic 11. An electrical cell is defined as a component that houses an internal chemical reaction that converts chemical energy into electrical energy to generate a voltage. Note that batteries are just one or more connected electrical cells. There are two types of electrical cells, primary and secondary cells. Primary cells house internal reactions that are non-reversible, and thus not rechargeable. Once the internal reaction is complete, the cell is thrown away. A common example is a household alkaline battery. Secondary cells house internal reactions that are reversible and thus rechargeable by using a higher voltage DC power supply in the opposite direction of the cell. A common example is a lithium-ion battery. You've now reached the end of the preview for this IB Science video. If you want to check out the full video, head over to our website and select a membership plan today.